board, this is an is equal to 5an minus 1 minus 6an minus 2, and if you've watched the previous two videos, you'll know why I'm asking this question. What is the degree of this? It's 2. And so we're going to write a function of x corresponding to this homogeneous recurrence relation, and so that is going to have degree 2 as well, plus some x, some constant plus, x to the some constant times x to the 0. And so what are those constants? Well, we have our first constant is 5, and so and our second constant is negative 6. But we're not going to plug those directly in. We're actually going to flip them and make them negative 5 and 6 before plugging them in. So this is going to be negative 5. This is going to be 6. And so we have x squared minus 5x plus 6 is equal to 0, because this is homogeneous, and a homogeneous equation is equal to 0. And so we can solve for the roots of this is x minus 2, x minus 3, and so x is equal to 2 and 3. And so the roots of our equation are 2 and 3. And so now we can plug this in to this equation. So sigma 1 times, and so plugging these in, we get sigma 1. What was R1? 2. Right? Yeah, I think so. 2 to the n. You always do minus. Or no, sorry, you do not always do minus, but in this case, our homogeneous equation was 5a to the n minus 1 minus 6a to the n minus 2, and so we also do a minus here for the second term, minus the second term, which is sigma 2. Right, the second term in the original equation was 6a to the n minus 2. Sigma 2 times, what was R2? It was 3 to the n. And we can set this equal to a to the n, right? That's our function, and by definition, I guess that's what we set it equal to. And so a0 is 1 and a1 is 0. And so let's plug these in, right? Equals 0, which is equal to a0, right? So at a0 we get, at a0 we get 1. Let me erase that. And at a1 we get 0. So plugging that in, we get, this is 1, yeah, is equal to sigma 1 times 2 to the 1 minus sigma 2 times 3 to the 1. Ah, crap, this is to the 0, to the 0. Sorry, sigma 1, 2 to the 0 minus sigma 2, 3 to the 0 is equal to 1. And we also have sigma 1 times 2 to the 1 minus sigma 2 times 2 to the 2 is equal to 0. And so we have these two equations, and let's solve for them really fast. We know that sigma 1 minus sigma 2, right, this is using this first equation here, is equal to 1. And we know that 2 sigma 1 minus, what is that, 4 sigma 2, right? No, this is 3 to the 1, right? Yes, minus 3 sigma 2 is equal to 0. And so now we can actually plug these in, and we can say that, God, let's not do this the short way, let's do this the fast way. And so I'm going to subtract, this is equation 1, and this is equation 2, and we get, let's erase some stuff up here, right, because I need to still look at these equations. Could I get a bigger eraser, please? And so, right, that should be enough room, more or less. And so I'm going to subtract equation 2 times equation 1 from equation 2, and that's going to look like this. 2 times 1 is E1. 2E1 minus E2. I'm gonna do 2E1 minus E2 rather than E2 minus 2E1. And that's going to give me 0 sigma 1 plus sigma 2 is equal to 2. And so you know that sigma 1 is equal to 2. Right, do you? Is that right? Let me just double check my algebra here. Oh, sorry, you know that sigma 2 is equal to 2. I'm fairly sure that that's right? I could quickly double check that, and if, okay, so if that's true, then, sigma 1 minus sigma 2, which is 2, is equal to 1, right? And so sigma 1 is equal to 3. And so this looks right. We get, what do we get? 3, right, which is sigma 1, which is 3, times 2 to the n, right, because R1 was 2, minus sigma 2 times R1, which is, R2, which is 3, to the n is equal to a to the n, and you're done. Right, so let's write these out. Sigma 1, R1, sigma 2, R2, right? And so that's it.